This mat is used to give meaning to computation with fractions, specifically subtraction with uncommon denominators. It allows students to begin learning conceptually how to change an equation with two uncommon denominators to one with common denominators, allowing one fraction to easily be subtracted from another. Let's begin using this mat by working with the models only. Clicking on the linking buttons links the equation to the models. After linking both levels, let's hide the equations so just the models are showing. Clicking on the tabs changes the model. The circle models or vertical bars will work best for this example, so we'll use the default circle models for this demonstration. We'll set the models to show the equation 3/5 minus 1/3. Next, we'll drag the first fraction over to the second to help students see that the individual parts of the first fraction are not equal to the second. Ask them how we can change the problem into one where the parts of both models are partitioned into the same size. Only when the parts of the two models are the same size can we complete the operation. Moving the sliders and moving between the two models allows students to make and check their predictions. This may take a number of trials before students realize that thirds and fifths have a common multiple of 15. Once the parts are the same size, show the equation and ask students, now that the parts are of equal size, are the denominators the same? Provide students with many opportunities to practice with and without linking. Next, move on to practicing with models that are not linked with the equation, in which the equation and the models are visible. Use the same steps as previously modeled, but now create an equation and then use the models to find the common denominator. Since the equation and models are not linked, you will need to enter the number into the equation below. After working from the models, show the procedural steps by linking and showing both levels of the equation and entering the numbers. You can choose at this point to hide the models. However, they can be used to supply supportive feedback to students who are not fluent with basic facts. Notice that as I enter the example 1/2 minus 1/8, I enter the denominator first so that students develop a firm understanding of the whole unit and how it is partitioned prior to selecting the parts. I explain that the common denominator is 8, so 1/2 is multiplied by 4/4, or 4/4. As a result of modeling and rewriting fractions into a format that makes them easy to subtract, students will come to understand the process of getting a common denominator is really one of looking for a way to change the equation without really changing the problem.